Now that we know a little bit about the structure of an atom, let's look at how the structure of an atom, especially in terms of how many electrons that atom has, determines where that atom will fall in the periodic table. Now, I know that you know that atomic number, did I say it enough times? Atomic number is the number of protons, and you don't have to be a genius to see that the periodic table is organized by atomic number. 1, 2, 3, 4, 5. Do you see what I did here? I left out those 10 rows, 10 columns that I told you we weren't going to be interested in. And what I want to focus on at the moment are the periods. So these are the rows, and they correspond 1, 2, 3, 4. They correspond to where the outermost electrons are found. If the outermost electrons of an atom are found in the first energy level, then that atom is in period number 1. If it has electrons out here in the second level, it's in period number 2, and so on. Now, I know this probably makes you want to curl up in a ball and cry for mommy, but hold on, because we're going to make some sense of this. There is a formula that tells us what the maximum number of electrons in each of these energy levels can be. And that's important. So the formula is 2n squared. And n is these numbers over here. So n is 4, 3, 2, or 1. So we're again going to make ourselves a table. N, 1, 2, 3, 4. If you're getting dizzy, just put your head between your knees. It'll be fine. Maximum number of electrons. Okay, so in the first energy level, n is equal to 1. So the maximum number of electrons is 2 times 1 squared. 1 squared is 1. So that's 2 electrons maximum that I can have right there in that very first energy level. Then if I go out to the second energy level, here n is equal to 2. So 2 squared is 2 times 2. That's 4 times 2. That's 8 electrons. So in the second level, I can have a maximum of 8. 2 third level squared. 3 squared is 9 times 2 is 18 electrons in the third energy level. I'm just trying to keep my numbers from falling over each other. And the fourth energy level, and this is kind of overkill, 4 squared is 16 times 2 is 32. We are so not going that far. But that means there's a maximum of 32 electrons that can go in this energy level out here. So that's rule number 1. And we are going to pay attention to it. But rule number 2 is if you're looking at the outermost energy level, you can only have 8 electrons there. Now, I know this probably makes no sense to you, but just hold on. What we're going to do at the next slide is we're going to essentially build a periodic table, as I've done here, by drawing atoms. Don't panic. You can do it. I can't quite get everything I want on a piece of paper. So what I've done is I've done these atoms. Do you see what I'm doing here? Just to let you know where we are. I'm not going to do all of these with you. I think you'll probably be able to do them yourself once you understand the trend and what it is I'm getting at. I did all of these. And here's what we just did. We looked at in the first shell, the second shell, and the third shell, and what the maximum number of electrons you can have in there. And we're going to talk about this later. Here's hydrogen. Remember, 1 proton, and so 1 electron, and that's the atom of hydrogen. Would you like it if I did that? A little more easy to understand. So if there's an atom that has 2 electrons, and if you go way over there, you see there's helium, which has 2 protons. So I'm going to draw, let's just say I do it like this, 2 electrons. There I have it, right? Same number of protons as there are electrons. So that's an atom of helium. Now, here's what I've done. Not only have I drawn the atom of helium, but I have completed the innermost shell, right? N is equal to 1. I've maxed it out. So I've completed the first row of the periodic table, or the first period. So if I have an atom that has more than 2 electrons, and I have a whole bunch of those, then they have to go somewhere below this on the periodic table. So let's go to number 3. Number 3 is lithium, and it has 3 protons, so it's going to have 3 electrons. Well, the first 2 are going to be here in the first energy level, and the third one, the final one, is going to begin, it's going to be the first electron that's placed in the second energy level, and so we go. So here's beryllium. It has 4 protons, so 2 electrons are there, and now I have 2 electrons there. That's my 4 electrons, okay? I'm skipping over number 5 just because I had no room for it. Here's carbon, really important in all of biology. So it has 6 electrons. Well, there are always 2 in the first energy level once I've filled it. And now I have 4 left, so they're going to go here in the second level. What else do I have? Oxygen, can you draw that one? I have 8 electrons to place. 2 can go in the first level and 6 in the second. Can I do 6 in the second level? Yes, I can, because if n is equal to 2, I can do as many as 8 electrons. Well, I skipped over fluorine because I had no room for it, number 9, but I put neon, which is number 10. So I have 10 electrons to place. Let's see. I'll put 2, just like helium, and I have 8 more, so 8, that fills the second energy level. See there, I'm at the maximum number of electrons for this energy level, and I'm in the 8th, oh, my numbers are out of sync. Should be 3, 4, 5, 6, 7, are you catching on? We're in the 8th group, and we have 8 electrons in the outer shell. So let's see, if I had an atom that had 11 protons, I bet it's over in the first group again. There it is, sodium. It's going to have 11 electrons. So 2 here. I can put 8, remember, just like neon. That's 10, and I have 1 more. That's 1 electron. 2, 8, 1. That's 11 electrons. And look where it is. It's in group 1. Look at that. 1 electron for sodium. I'm sorry, that's hydrogen. 1 electron in the outer level for lithium, and 1 electron in the outer level for sodium. They're in group 1. Do you see a pattern? Now, let's jump way over to number 18. I have 18 protons, so I'm going to have 18 electrons. Now, let's see what I can do with them. I can put 2 here. I can put 8 here. Now, what's the maximum? I could have as many as 18 electrons in the outer energy level, but I don't need that many. I've got 18 total, and I've already delivered 10. So I really only need 8 more electrons. Let's see. That's 10 plus 8. That's 18. It matches the number of protons. The 8th group is represented by atoms that have this going on for them. 8 electrons in the outer energy level, except for helium, which is the oddball because it just doesn't have that many electrons. You see the pattern? So we're going to talk about how ions and covalent bonds form in such a way that they try to mimic this electron configuration. They try to get themselves into a situation where they have 8 electrons in their outermost energy level.